The user starts by specifying the most important color called the key color. Let's take yellow for this demo. If we need more colors for related but different objects, we can ask the tool for a so-called analogous harmony centered around the key color. The generated harmonious colors are symmetries in this color space. Asking for an analogous harmony produces 4 additional colors spaced uniformly around the key color. Colors not needed for the particular illustration are simply deleted. For contrasting objects, 1 or 2 complementary colors can be requested. In the first case, ProtoPalette produces the direct complement by incrementing the hue angle 180 degrees. In the second case, the 2 triadic complements, that is, the hues at plus and minus 120 degrees, are generated. If we need variations on one of these hues, we can do this by requesting lightness variations and deleting the unneeded ones. Finally, we can add chroma variations, typically used to confer depth to the picture, since vivid colors are perceived to stand in front of duller colors. When we are done, we can examine our palette and vary the key color. Note how the whole palette tracks the change of the key color. Starting with the correct colors is like having a special color box for every application. Here we see some palettes. In a sophisticated illustration, we need fine variations on the basic colors. Like the wash we saw in the paint palette, we create a digital wash in our color tool. We can select 2 colors, and the tool now displays all intermediate colors. We can pick one by selecting it. As you see, it is added in front of the palette. If we do not like it, we can simply delete it and make another selection. The wash is generated by interpolating linearly between the 2 colors in the perceptually uniform color space shown earlier. Successive interpolation, or mixing, can be used to generate difficult-to-determine colors such as skin tones. First, we select 2 extremal colors. Now we select the best interpolation. Since it is not yet close enough, we simply iterate the process by making a new wash using the new color as one of the endpoints. Remember that on your video, these colors may not look at all like skin tones because the equipment is not calibrated. Let's bring up the palette we created earlier with the ProtoPalette. Here we can use the wash to create all intermediate lightness values of a color. By selecting the darkest and the lightest value, we obtain a wash containing all possible values of the color. We use the metaphor of applying turpentine to the illustration so that the colors can be adjusted. After typing the turpentine command for the illustration, it is displayed in color. We can edit lightness, hue, and chroma for each color in the illustration. We said earlier that these color selection tools are based on the Xerox color encoding standard so that they are device independent. In the real world, not all devices are calibrated. For such devices, we can perform a very rough approximation of the calibration by rendering half a dozen colors and measuring them with a colorimeter. While not accurate enough to qualify for true device-independent color reproduction, it can prove useful for color selection. This approximation also gives us the ability to roughly predict how the illustration will look on a particular device. Here we see it for an electrostatic plotter, a thermal transfer printer, an offset press, and a variety of color monitors. The simulation is based only on a very rough linear interpolation, but it gives a handle on the final appearance of the illustration. By switching between different devices, the user gets just a hint of how the colors can change from device to device.